Assalamualaikum dan salam sejahtera. Today we continue our lectures about boundary layers. So I will show you a few questions to solve boundary layer problems. So here, this is question number 4. So in question number 4, a laminar boundary layer velocity profile is given by f eta, function of eta, equal to 2 eta minus 2 eta cube plus eta by the power of 4. Okay, so the symbol of this one is called eta. Okay, so here, so what happened to this one? So this is actually, we simplify the velocity distribution. Previously, I think you already know that we use u over u. So now, because u over u, we have a little bit difficulties to integrate the value of u over u, especially when the power is bigger and bigger. So kalau awak nampak, sebelum ini kita menggunakan u over u. So kita akan menghadapi masalah untuk integrate kerana ia menghasilkan proses yang agak complicated. Yang tidaklah terlalu complicated tetapi agak sukar. Okay, kerana dia ada per. Okay. Oleh itu, mathematician ataupun kita kata ada cara mudah untuk kita menyelesaikan masalah tersebut, iaitu kita menggantikan nilai u over u di sini dengan sebutan eta. Okay, jadi what happened? That's why in this question we have this kind of assumption where u over u is equal to f eta. So f eta here means function of eta. Eta. So actually you could replace with any alphabet. So for example, if you want to say that u over u is equal to z, so now it's become function of z. So it's depend on you. But normally in boundary layer textbooks, they will use eta because after this, I will show you another solution. So it's proposed to use symbol of eta. So that's why we use eta here. Okay, so this is the question. So a laminar boundary layer velocity profile is given by 2 eta minus 2 eta cube plus eta by the power of 4, where function of eta is equal to u over u and eta is equal to y over delta. So the question is, determine the value of delta star over delta and theta over delta. So we know previously in our previous lecture, we know that when the power of 4 here, we could write it as u eta equal to 2y over delta minus y over delta by the power of 3 and y plus y over delta by the power of 4. If you see this velocity profile, by using this assumption, we could write as function of eta equal to 2 eta minus 2 eta cube plus eta by the power of 4. So I hope you could understand the meaning of these changes. Okay, so when we change the terms from u over u to eta, so we need to change the limit of the integration. So please bear in mind, please remember that the equation for delta star is shown like this. So delta star is equal to integration of 1 minus u over u dy. So in this integration form, we use dy. But because we change the value of u over u into eta, so means that we need to change this equation too. So how to change this equation? So you must know this idea. So first, we know from our assumption, eta is equal y over delta, and then if we derive it, we differentiate it. So we differentiate as d eta dy. So, and then we could get it is equal to d eta equal dy d theta, dy delta. So, and then if we rearrange this one, so we could write dy is actually delta times eta. Okay, so when we use this term, we need to replace the dy here with this value. So means that our equation from 1 minus u over u here, 1 minus u over u dy, it will become 1 minus function of eta, f eta, and delta d eta. So this delta d eta is actually we get from this 1. So we replace the dy here, so with the value of delta d eta. Okay, this is the first step. So, and then we also need to change the limits here. Okay, because the limits here is actually depends on the value of y. Okay, please remember that if we have a flat plate here, so we have a boundary layer, then okay, we have a delta here. So the delta here is actually in y axis. So that's why we integrate with dy here. So and then the limit is become 0, which is this point, and the value of delta, which is this point. Okay, so now we change the value of dy here, so means we also need to change the value of this limit. So how to change the limit? So you may use this idea. Okay, so we assume that, okay, so you may use this equation. Okay, for example, from this equation, you could write y is equal eta and delta. So you know that when y equal to 0, so when y equal to 0 here, so the eta must be equal to 0. Because delta is actually constant. Okay. Delta must be exist. Okay, delta ataupun boundary layer thickness mesti wujud. Oleh itu, boundary layer thickness mesti ada nilai. So di sini antara dua sebutan eta dan juga delta, so eta perlu menjadi kosong. So that's why we could get this first condition. And the second condition here is if y equal to delta, so we have y equal eta and delta. So if y here equal to delta, so we found that eta here must equal to 1. Okay, that's why we get this limit. So now means our equation to calculate the value of delta star or the displacement thickness is changed from here to this term. Okay, so bear in mind if, okay, so the idea is if your velocity profile is u over capital U, so you need to use this equation. So if your equation, your velocity profile is in function of eta, so your velocity, your equation of delta star must be written in this form. Okay, sampai sini okay ke? Okay, so maksudnya awak kena faham, okay, walaupun soalan ini diberi dalam bentuk yang berbeza, kita masih menggunakan pendekatan yang sama untuk mencari nilai delta star dan juga theta. Okay, walau bagaimanapun, oleh kerana equation ini telah berubah daripada bentuk yang common, u over u, kepada bentuk function of eta, kita juga perlu untuk menukarkan equation. So, iaitu equation untuk delta star berubah daripada nilai ini kepada nilai ini. Okay, cara perubahan saya telah tunjukkan. Oleh itu, saya ringkaskan di sini. So, the equation for displacement thickness will become like this one. So, means that it's become delta star over delta. It is equal of integral of 0 to 1, 1 minus function of eta d eta. So, this delta is actually come from the left, right hand side here. So, we bring it to the left hand side. So, and then you could do the same things. Okay, you could change the equation for theta. And if you change the equation for momentum thickness, so you will get this term. So you will get theta over delta. It is equal to integration 0 to 1 function of eta 1 minus function of eta d eta. Okay, I hope you could remember this equation because the integration process using this equation is quite simple. Okay, let's say we go for our question. If our velocity profile is like this, 2 eta minus 2 eta cube plus eta by the power of 4. So if we need to calculate what is the ratio of delta star over delta here, so we use this equation. So we substitute the value of eta here with what we have here. So and then we could get this term. So and then by using this term, we could integrate it. Okay, we do the integration. So I think you already know because we have eta here and then we integrate with d eta here. So we could get this one and we substitute the limit of 0 to 1. So then we could get delta star over delta, it is equal to 3 over 10. So this answer is actually same when you are using u over capital U, or you're using the idea of function of eta. So this equation actually can be used, okay, this method of solution can be used for any velocity profile. So for example, if you have u over u, it is equal to y over delta. So you could say that it is equal to function of eta, which is equal to eta. So you may use any kind of velocity profile and convert it into function of eta. So and then I simplified it here. I hope you try it at home. So if you want to calculate to determine the value of theta, so we substitute the value of function of eta inside our new equation here. So it is integration 0, 1 function of eta 1 minus function of eta d eta. And then you could get the final answer as 37 over 315.